Classifying triangles by the angles, they have 4 different names. You have acute triangles.
There we go.
Acute little angles are all less than 90, but acute triangles have all 3 angles less than 90. Let's draw one on your green paper.
I'm a cute triangle.
Acute triangle.
So selfish.
Obtuse triangle. One angle is obtuse and greater than 90. So if I draw one obtuse angle, could I make a triangle by
Yes.
drawing another obtuse angle?
No.
No, that would have to extend beyond, and you'd have another figure that would create. So there's only one obtuse angle and 2 acute angles in each obtuse
So
triangle.
could you have like a 179 degree obtuse angle?
Probably. Half and half, I guess, maybe, if it was isosceles, but it would be almost looking just like a line. Okay, right triangle has one right angle, so draw a picture of one of those, if I can make my right angle look correct. Can you have more than one right angle in a right triangle?
No.
No. So once again on this, that 90, subtract from 180, you're only left with 90 degrees that you have to have 2 angles that are made out of. So I guess you could have a 1 degree and an 89 degree and have a really small, thin triangle. Okay, then equiangular, equal angles, equiangular, equiangular, I don't know how you pronounce it. Triangle. All angles equal 60 degrees. So next to that, draw your acute triangle, but put markings on all 3 angles. They are all 60 because if you took your 180 divided by 3, you've got 60 in each angle. So all equal angles. Okay, so that's the 4 ways to classify by the angles. We'll come back to this picture in just a second. To classify by the side lengths, we'll see if you guys remember the names of these triangles. 3 equal sides, equilateral, equilateral, 3 equal sides. Did y'all ever learn the song?
No.
Like 3rd grade.
Okay,
Oh,
so
I was
make a
in
marking
third
on your
grade.
triangle for that, please. Equilateral, 3 equal sides next to that on the green paper.
Oh, that's why. I was like, why is there a bicycle?
Oh yeah, I'll bring that up in a minute. Isosceles triangle, 2 equal sides. So an isosceles triangle could be a right triangle. It could be an obtuse triangle. I think I'll just draw one as an obtuse. And then you have 2 equal sides. Or if I drew it this way, it actually looks like the eyes of my triangle, or eyelashes, I guess. And that's 2 isosceles.
I. Well, what if you're a cyclops or a triclops?
Then you're non-existent. Only fictional character, right?
Cyclopses and triclopses do exist.
Anyway, back to scaling.
Like, not.
We have a scaling triangle with no congruent sides. So you
they're
have
all
a short side, a medium side length, and then a long side. Unless your triangle is a right triangle and isosceles, most right triangles are scaling. So all 3 sides are different lengths. So yes, I throw in pictures here occasionally because I want you to recognize that as we start working more and more and more with triangles, there's so much triangle stuff, to be honest. There's even a whole class based on triangles. Trigonometry. It's all based on triangles. So as we work more and more with triangles, and the things that we go through this year, I like to pull in why you need this. And so if you are in manufacturing, if you are in construction, you will run across things that work with triangles pretty much. So even in the manufacturing of the metal frame of the tricycle, of the bicycle, you've got your triangles in there. Okay, so going back to this problem right here. In triangles, I want you to draw this in your journal as an example. In triangles that have equal sides or equal angles, we can throw in algebra in the way that you can make equations and solve for variables.
Notice how you said in the way.
I drew the bicycle. It's a lot better than everyone else.
Okay, so looking at this picture of this triangle, Skylar, what kind of triangle is it?
It's an isosceles triangle.
Yes, and why do you know that?
Because it has the markings that show that 2 of the sides are equal.
Correct. So if my goal on this problem is to ask you to find the value of x and the value or the length of the sides. anybody, what should we do to find the value of x?
You could set up a set of equations.
5x equals 3x plus 12.
Yes, because of the markings, you have two equal side lengths, so you make your equation like that. 5x equals 3x plus 12
And then 5x
and solve.
times 2 equals,
X equals
like, whatever.
Subtract 3 divided by 2.
12.
X equals 6.
And then after the divide by 2,
3. Oh, you're stupid.
x equals 6. Okay.
Just coughs. Your IQ lowers by 5 points.
All right, guys, come on.
What if your IQ
We have our
It's negative. Oh, yeah.
negative?
We have our value of x. Now we can go back and find side lengths. I like how y'all did not say this plus this equals 180.
I was gonna say that, but you cut me off.
And you said I saw silly. So why do I not add these to equal 180?
Because
then you
those
can
aren't
find-
angles.
Right. The 180 only occurs from the three angles. We know that automatically for your triangle, but these are representing side lengths, so the degrees do not mesh with the side lengths, therefore we cannot make them work together. But by congruent markings, we know that those are equal to solve. Now, when we go back, Tyson, how long is this side length?
30.
Yes, 5 times 6, 30. Kyle, how long is this side length?
30.
Yes, because they are the same. And then Holly, how long will this one be? 6 times 7?
52.
Minus 10.
30.
I'm a failure. 32.
Oh, so I can
42 minus 10, 32. Almost equilateral. But this is another good time to point out that does not look like 30, 30, and 32, right?
Nope.
They are definitely different lengths than that. So don't go by the looks of the picture. You go by the variables that are there. Okay, so there's that. Now let's talk about congruent figures in general. You should come to the next part of your green page that looks like this. Congruent triangles, congruent anything, same size, same shape. Congruent triangles specifically have this definition down here. So I'm going to point to this. Here. Congruent triangles, yes, same size, same shape, but here's your actual definition. It's all corresponding parts of congruent triangles are congruent. There is an abbreviation that goes with that we typically don't use, but I want you to know what it stands for. Corresponding parts of congruent triangles are congruent. So it's basically the definition of congruent triangles. What that means is in two different triangles, you have 6 sets of corresponding parts. You have 3 sides, AC to GE, AB to EF, and CB to GF that are corresponding. They're in the same position. They should be congruent. You have 3 angles, A to E, C to G, B to F, that are corresponding, that should be congruent. And if you have all 6 parts, then you should have congruent triangles. Okay? So what I would like to do with this concept is a quick little example of maybe a 5-sided figure. And let's go away from the triangles for a minute and think in terms of just congruent figures in general, because all of the rules that apply for congruent triangles will apply for other figures as well. Also, if I took triangle ABC here and I move it like is here on this picture, it doesn't change size, right? But what if I took it and flipped it over? Does that make it change size?
No.
No, that's a reflection, and that does not make it change size either. What if I rotate or turn it?
No.
No, does not change size. So you can have congruent figures that are not facing the exact same direction. Maybe they're rotated, maybe they're turned, maybe they've just been twisted around somewhere. But they're not always going to look like they're in the same order like this. Go here. So you don't have this, but that just kind of described what we talked about. You can move them, translate them, you can reflect them, flip them, you can rotate them, turn them, and they stay the same size. Okay, example in your journal. Please draw with me. Can we draw a pentagon?
What?
Like a doghouse?
Maybe.
Do a
That's scary.
rooftop?
Yep.
Kind of bring the sides down.
Wow, it's the White House.
Pentagon. Do another pentagon next to
That's
it because we're going to
green.
have congruent
The
figures, same
hexagon.
size, same shape. And we're gonna, oh, well, maybe mine's a little bit bigger over here, but we're gonna pretend they're the same size and the same shape. This one is going to be figure A, B, C, D, E. I'm gonna start my A, B, C, D, E by labeling them. Kyle, where's your journal?
But it's
Skylar.
pretty.
Sorry, I was
It's
drawing a
journal.
pentagram in this journal.
It's pretty spiritual now.
Okay, on this one, I want to say that they're congruent, and I'm going to name it MNOP. Q looks like O, so I'm going to skip and do R.
Just
Okay.
like the scientists that did the vitamins.
But what I want to do is write those letters so they are a reflection. Okay, so yes, this looks like it's this piece, but I want to think of it as reflected. So this is going to be M, N, O, P, and R.
Monopoly.
Okay, so this is practicing for what's going to be on your homework. All right, we have congruent figures. I'm telling you they are congruent. I'm going to go through and we are going to together, we're going to write all of the congruent parts. So there are 10 sets of things that are congruent, 5 sets of angles, and 5 sets of sides. Find one of the matching sides that are congruent from figure to figure, Tyson.
A, B, R, and
Good. Let's put a tick mark there, and I'm going to start just listing them. A B segment is congruent to RM segment. Okay. So Tyson knew that they were both the bottom of the pentagon. But look up here also. You can tell if these letters are written in the correct order, and they should be. You can tell by even looking here. AB corresponds with MN. Okay. So for us to know that this is reflected, I really know not that EA and PR are the same. I know that EA and MR are the same. EA, this one, and wait. Did I not do that right? M.
that means like E is
Wrote
DC,
this
Oh no,
computer
I didn't do my
across
letters
the
right.
room.
Oh man.
and nobody likes DC.
What?
Sorry guys, I did my letters in the wrong spot. I have to go M N O P R. Okay, better. EA and MR, EA and MR should be the same. Did y'all change yours?
Yes.
Sorry. My mistake. I wasn't paying attention as I wrote them down.
Oh my gosh.
It feels like a Monday to me.
Wouldn't it be
I started
ME?
writing these down correctly.
Oh, I see. Never mind.
And then I didn't.
So I
write
did them
correctly.
in a reverse order because I
was
wanted to see a
hitting my
reflection.
desk.
Okay, so what my ultimate goal here is to get all 5 sets of corresponding sides. But I want you to see that you don't have to get them from your picture. You can always get them from here. So AE corresponds with, now it's better on my picture, MR. AE congruent to MR. And we'll do tick marks here and here. 2 tick marks because they're not the same length.
Tick, tick,
Okay, Kyle, pick another set that's congruent.
P-O-D-E.
And I'm gonna look here. PO can't be with DE.
P-O-O-P.
OP and PO, same thing. But look what it has to correspond with.
C-D.
CD. Okay? So instead of ED, because that's a reflection, I'm looking in these letters, they're really telling me even better than the picture. Okay? So PO is congruent to CD. CD. Okay, another set. Holly.
PR and DE.
Okay. PR and DE, yes, and they were the reflected ones. So 1, 2, 3, 4, 1, 2, 3, 4, and
This is
PR.
too many lines.
congruent to.
Never really touching anything.
All right, Skylar, the last set of
AB
congruent
and NN.
segments.
Oh, so-
Or did we already do that?
Sky
CB?
CB
And-
corresponds with.
RM.
B-C.
What? Oh,
So,
because it's like a, okay.
because I
sorry.
reflected it, so CB corresponds with.
No!
Yes, it does. CB congruent to PO. Okay. All right. So we found all of the corresponding sides that are congruent. Now let's find angles that match up. I'm gonna write them as you tell them to. So angle A corresponds, Tyson, with
N. Wait,
which one?
N.
Angle A with
Oh, M.
angle M. Remember, it's a reflection.
Oh,
Okay. And so also be watching up here. A with M. Angle B, Holly, with
Angle N.
angle N. Angle C, Skylar, with
Angle C with angle O.
Code.
Kyle, angle D with
angle P.
P. Yes, that one actually looks the same. D, P here. And then finally, angle E congruent to anybody.
R.
R. Okay.
We're not friends.
All right. I think you have the idea of the congruence. Now let's talk about the triangle theorem that we put into your journal also, and then we'll get our assignment.
Perfect.
So, come on, guys. Okay. 4 people and
Get it together, Holly.
sit still in here. So, the third angle theorem, let's see if this makes sense. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles have to be congruent. Okay, the words don't make as much sense as if I put numbers there.
Oh, well, that hurt.
Yes.
Okay, no, I agree with that. If this is 40, what do I know about this angle if they are just a translation?
It's 40.
It's 40. That's one set of angles. If this is 80, what do I know about this angle?
80.
Another set of angles.
80.
Why does that third angle have to be the same if these are the only 2 I know?
Because that's the only way it would add up to
180.
Exactly. Together, these are 120. So what does this angle have to be?
60.
60.
And the same thing over there because that's the only way that they will be 180. So in any 2 sets of triangles, you don't necessarily have to have the third angle marked. If you know 2 are the same, then the third is already going to be the same. Okay. So this would have to equal, oops, that's a 60, and this would have to equal a 60. So the third angles will be congruent. Okay. All right, that's pretty much the lesson for